Hello, ladies and gentlemen. I am Vakti Zakir from the Tashkent State Transport University. I inform my article's presentation with the topic of assessment of the service efficiency using public service models. In today's complicated market economy, the greater competition necessitates improving the quality and efficiency of service supplied as well as sectors. All sectors. This in turn indicates the need to introduce new type of service, improve service quality, and develop new methods for assessing their effectiveness. The significance of topic has prompted various significant investigations. The most common models in this direction is five-stage model to service quality assessment proposed by a group of scientists. This model is also called the Service Quality Model or JATCA. Based on it, a practical method called ServQual has been developed for assessing service quality. These methods are based on assessing the difference between the perceived quality of service offered and the quality of organizing offering it. This difference is determined based on statistical process of the result obtained through the questionnaire of differences. Another widely used method for assessing the quality of service provided is the mystery shopping method. This method is also based on statistical process of the user survey and requires a little more resources than the circular method. The widespread use of the internet service has contributed to the popularity of this method. The main idea of this method for assessing the quality of services provided is the reviewed work in statistical processing of the opinions of service users and their results. The service user is the most important integral element in the service delivery system, expressing his subjective opinion about the quality of service provided and his participation in this service delivery process, which allows this method to be implemented. With this method, the customer evaluates the visible part of the element involved in the service process. However, this process is the result of invisible activities of the service organization. Using this method, the user assesses the visible aspects of the service process, but this process is the result of the invisible activity of the service organization. But on the method considered, the level of satisfaction of service users is determined, and on a basis, the service enterprise determines its technical and economic indicators. In contrast with the previous methods, the suggested method determines the service quality indicator using an objective function that includes expression of organism. The advantages acquired from providing this service and the benefits lost by the users. The mathematical expression of the objective function and the quality indicator of the service given is determined using mathematical model for the theory of public service provision. In our work, objective function and their elements will be like this to evaluate the process of providing service to users in accordance with a specific quality standard, and mathematical model of the system must be developed. The mathematical model being created aims to analytically express how the system responds to external influences. The service system will be like this, and external influence can be seen as the flow of requests and requests generated by users. The system's response to the flow of requests is described based on its state. Whether the service devices are busy or free the state of the waiting areas, the waiting time for the service to start, and so on. Considering that the flow of external influences from the user occurs at random moments in time and the randomness of the service system's response to this flow, it is appropriate to use a mathematical model of queuing theory to represent this process in a mathematical form. It is known that the mathematical model of queuing theory consists of the following elements: the flow of requests entering the service system, such requests from the input flow. The model requires a mathematical expression of the flow to be determined. The time is taken to the system to service each request. This time is determined by the occupied time or bit time of the service device. In order to service incoming requests, the internal structure of the service devices. For example, the most commonly used model in the service systems MMR less than the infinitive. Let's determine the quality indicator of this model. The probability of losing application in the combined service system will be like this. And also probability of waiting longer than allowed time will be like that. And also the probability of waiting for the request to be served will be like this expression. The results from our research, the following technical and economic parameters of the company depend on the level of service, quality of service, of course, costs associated with the organization of the provision of service, K1, and income received by the company from the service, quality, K2, and social costs is costly. K1 will be like that, and here CP will be comes from this function, and also EP is the operating cost, and also loss of our income or cash will be like that, and also the cost of lost customer time. It is costly will be like this expression, and here C3 average per unit of the customer time, and N is the number of customers, and also gamma waiting time. And also our results show this diagram, and we can calculate from our research like that. As the number of service devices increase, the cost required to organize service provisions also increase. However, the lost income decrease and the time lost by the users to receive service also decrease. At the certain value of service device, the objective function reaches its minimum value. The number of service devices corresponding to value determines the optimal value of the quality of service. Therefore, it is possible to evaluate the efficiency of service system using public service models. To do this, it is necessary to select a model suitable for the service system, and also based on it, determine the value of the objective function and optimize it. It is possible to compare the optimal values with the values obtained using current available methods, and based on this, select the quality of service that takes into account interest in both service users and service providers. Thanks for all the conferences attendations, and good luck for your future work.